Hello, my name is Dr. Rumman Chowdhury, and for the next hour, we will be discussing ethics and risks in AI deployment implications for business and society. I am the CEO and co founder of the tech nonprofit Humane Intelligence. In the Biden administration, I served as the first United States science envoy for AI, and I have worked across industry and companies like Accenture and Twitter, civil society, government, and created startups of my own in applied, ethical, and responsible AI. First, I ask, do you know who this man is? You might not, but what if I told you that he's the reason we're all alive today? Now, that may sound like an extreme statement, but it's actually not. His name is Stanislav Petrov, and in the 1980s, he worked for the Russian army. His role in the Russian army was to be essentially the human in the loop on nuclear deployment. In other words, there were advanced machine systems that would detect if the United States had sent a nuclear missile during the Cold War, and his job, if the alarm sensors went off, was to push a button to escalate the launch of Russian nuclear weapons. Now, one day he's sitting in his bunker underground and the alarm bells start ringing. Now, as the human in the loop of this technical system, his job was simply to push a button and carry the message forward. But luckily for all of us, he didn't. He used critical thinking skills. And in doing so, he thought, well, the issues between the US and Russia have not escalated recently, and there really isn't much reason to think that the US would take such an extreme move as to send nuclear weapons. So he decided to actually break the chain and ignore the system. And fortunately, he did, because there were no nuclear weapons set off that day. And if he had simply followed what the machine had told him, we would be living in a very different society. Now, fortunately, he used critical thinking and working with AI and technology, but that's not always the case with artificial intelligence. So, what do we talk about when we talk about artificial intelligence? Well, we might see these headlines that read as if AI is taking our jobs tomorrow. Things like AI is just as good at diagnosing illness as humans, and that the solution to our education crisis might be AI, and maybe that lawyers could be the next profession replaced by computers. Now, importantly, every single one of these headlines predates generative AI. What if I told you that all of these headlines came from before 2020? Now, in other words, we have been talking about AI as a technology as if it was going to replace us for a very long time. And I'm here to discuss pragmatic and practical ways in which humans and AI machines, however sophisticated they may be, will always need to work together. And importantly, just like Mr. Petrov, you as the human in the loop will always need to use your critical thinking and assessment skills. So often what people think AI is this photo of this white robot, often quite feminized for some reason, but it is a physical manifestation of a being that looks and talks and acts just like us, but happens to be significantly smarter. Now, here's your second question. Do you know where this image is from? Now, whenever I ask this question, most people think it's from the movie Ex Machina or some sort of modern science fiction film. What if I told you it's from a 1987 music video by the Icelandic artist Björk? Yes, our modern interpretation and understanding of what AI systems are was actually fabricated for a music video in the 1980s, which goes to show how much of what we think about AI lives in the realm of the imagination. And I'm here to drive it to practical and pragmatic application. So, what AI actually is what the screen looks like on the other side. In other words, it is simply code put into practice. And very specifically, this code is often mathematical functions. Now, these are quite advanced and sophisticated mathematical functions, but to be clear, AI is not alive, it is not thinking, it is not feeling, and it doesn't want or need a physical manifestation of a human body. So, why do we do that? Why do we create this mythology about AI being better than us, smarter than us, and often replacing us? Well, often what we're finding in how AI is being used, and your lesson number one, is to avoid something called the retrofit human, where we build a technology and then we tell society, we tell people that they have to adjust to the limitations of the AI system rather than adjusting the technology to serve humanity. So, lesson number one is always design technology to serve humanity. In other words, solve the human problem that you are trying to fix. AI systems will inherently have limitations because they are simply not as complex and able to perceive and adapt and adjust as human beings can. And because they cannot, AI systems will never be as good as people in many different ways. Now, instead of saying that human beings need to limit themselves in interacting with technology, let's figure out ways in which AI systems can actually adjust so that we are having our needs met. So, lesson number two, do you see anything interesting about this car? Now, I'll tell you a bit about this car. It is one of the earliest concept cars for a self driving vehicle, and this was presented at a car show about 20 years ago. And there's a few things you might notice. Number one is that there is no steering wheel. In other words, this car is truly expected to be driverless. You sit in it like you might sit in a bus or a private vehicle, and something else, in this case, a complicated AI system would be driving you somewhere. And this was the story we were promised. I'm going to give you an example today of what a retrofit human looks like. This is what we were promised. And when we all were told that we would have self-driving cars, this might be something what like we imagined. That we would wake up and there would be a vehicle sitting outside of our home, and we might get in, check our emails, possibly take a nap, arrive at work refreshed, having gotten some work done, and we could begin our day. So, none of the inconveniences and stresses of having to drive, but also none of the complications of having to take public transit. The reality is, we are at 2 to 3 for most, quote, driverless cars, and at a 4, a degree of high automation, quote unquote, high automation, for some of the cars you may see on the road, like Waymos. Now, the reality is, we have created this mechanism because we are not actually achieving the idea of full automation. While there are cars on the road today being called driverless or self driving. Now, instead, what we find is that these self driving vehicles require us as humans to absorb the worst of everything we try to avoid while driving, while still giving up autonomy. So, there's a term called the moral crumple zone, and it was coined by Madeline Eilish. Today, she's at Google. Now, while the crumple zone is a aspect of the car that is meant to protect a human driver, the moral crumple zone protects the integrity of the technological system at the expense of the human operator. Now, what does that mean? We have had multiple instances in which Tesla vehicles have caused accidents, and yet every single time that the human has often been responsible or considered liable. And in fact, this is why modern day, quote, self driving cars still have steering wheels. In other words, by putting the human at the center, having to make decisions and be responsible, and yet not giving autonomy and agency, we have told human beings that they have to adjust to the limits of a technological system. In other words, this is a retrofit human. Now, why is this bad? Well, the main reasons we wanted self-driving cars was that we did not want to have to be stressed out and concerned during our rides and to their commutes in the morning to work. And instead, what we've been given is a lack of autonomy, a lack of agency, and yet still all the stress and responsibility. Similarly, in 2018, there was a fatal crash of a self driving Uber, and the driver of the car was charged with negligent homicide. Now, again, this was a car that was called self driving, and yet, even though Uber had admitted and the engineers had admitted that the calibration of the systems was insufficient to have identified a person on the street, the person driving the car was still found to be responsible. Now, that is retrofit human in a nutshell. So which is it, right? So do we want quote unquote driverless cars? And what we're saying now is that entire states want to redesign road networks to accommodate driverless cars, even though that is in contrast to a people-friendly city, the La Ville du Côte d'Or or the 15-minute city. In other words, human beings live the best when we are within 15 minutes of all the things we need. So commuting by car can have a negative impact on health. And yet, because we have this presumption of a technology that is not quite there yet, there are some leaders that actually want to reimagine human spaces to optimize for technology. Now, this is the future to avoid. Now, what I want to talk about is how we can spot and identify what machine learning models are good at and they're not good at. So, I'm going to talk a little bit about how we build AI systems and what that means. So, first is appreciate that when you build a machine learning or an AI model, you're building for a quote average person. What does that mean specifically? So, what AI models and machine learning models are quite good at is identifying overarching patterns, parsing through massive amounts of information and identifying things that are similar to each other, and giving you outputs that are generally consistent. Now, what does that mean? This means that that AI and machine learning models are really good at solving problems that have a lot of data, a volume of data that have clear patterns built into it. In other words, there's a signal in the noise, and that they're pretty consistent. In other words, the output doesn't tend to change from situation to situation pretty significantly. Now, one can identify some ways in which machine learning and AI models would then be quite useful, right? This could be identifying things out of images, a lot of common use cases that we're building today. But you also appreciate here that, in other words, there needs to be an overarching pattern to the data. Sometimes there is not. That you need to have a volume of data that is significant enough for the AI system to be able to measure and calibrate that. That may not always be the case. And that for given similar inputs, you will consistently have similar outputs. And again, in the real world, which is a highly complex and messy place, that may not always be the case either. By the way, this is why self driving is incredibly hard to tackle. The patterns of the data may not always be consistent. People in different countries drive different ways, different sides and different rules may lead to different outcomes. And also, there's the human aspect, our human interconnected ways in which we communicate nonverbally with people on the road, bicyclists, a stray ball that may have a child after it, and more. So, actually, driving is a really, really hard problem to solve, even though it has something like a lot of data and it seems like something that might actually be easy and consistent. So I'm going to tell you a story about what average actually means. Because again, when you give an AI or machine learning model a massive amount of data and you say find a pattern, what it means is find the average of what this data could be. So, who is average and what is average? So, I'm going to tell you another story. In the late 1940s, pilot crashes in the United States Air Force were at an all time high. Now, this is post World War II. And what people in the Air Force realized in the military when they investigated these planes and the people sitting in them was that these seats had been built in the 1920s and they were built measuring hundreds of men across multiple dimensions and designing for the average man. So the presumption was maybe between 1920 to the late 1940s, nutrition had improved, healthcare had improved, and quite possibly men were just bigger because they were healthier, which is great. Now they realized, okay, well, now we need to go back and revise the system, redo the measurement, and recreate these seats because they're clearly insufficient for the pilots we have. So they redid that same exercise. Now, mind you, again, we have a setup where you have generally consistent inputs and outputs, right? In other words, the pilots tended to be structured and be rather similar. They're all men, they all tend to be younger, they're possibly a particular build, they're in the military. And measurements were taken, a 10-point measurement scale measured across 4,063 pilots to design the quote average pair. So, in other words, there are doctors that sat and measured over 4,000 pilots across 10 different dimensions, things like shoulder width, arm span, leg width, hip width, head to neck ratio, and designed the quote average chair. There's a new quiz for you. How many pilots do you think this suited? Of the 4,000, do you think it was maybe 3,000? Maybe it was half, maybe about 2,000, 1,000. Keep going lower. It suited nobody. Not a single pilot were the average dimensions. In other words, there was actually no such thing as an average. An average was a measurement that was taken that did not manifest or exist in reality. Now, why is that important? That is critically important because as you build AI systems, it may sound like if you have an impressive amount of data and a lot of measurement over a long period of time, that clearly that must mean that more data is giving you a better answer. Now, the problem here is that that may not always be the case. There may not be an average. In other words, the what an individual needs to suit their purposes may be highly specifically calibrated to that person. One of the most fascinating things about collecting data about people, and I've been doing this for 20 plus years at this point. I'm a quantitative social scientist by background. One of the most interesting things is that humanity as a whole, human beings, their aggregate behavior is measurable and fairly predictable, but to the individual, it is highly unpredictable and highly stochastic. Now, that is the most interesting thing to remember when talking about machine learning and AI systems. The aggregate measurement of human beings as a whole may be more predictable. You may have better data, better outcomes that are more predictable. However, if you are trying to target the individual, which, by the way, most AI and machine learning systems are trying to do, it is nearly impossible to calibrate to that person perfectly. So, as I mentioned, not a single pilot fit those dimensions. And you might say, well, 10-point measurement might be too many, right? Like nobody's going to fit the average of 10 points. What if it was only 3 points? What if you only took, let's say, height, shoulder width, and arm span? Even then, it was only a very small percentage of people. So, what did the military do? I know this is a lot of text, but it's quite an interesting article. You don't have to read it. I'm going to explain it to you. So, by discarding the average as the reference standard, what the Air Force did is they pushed this concept of individual fit. So, instead of fitting the individual to the chair, what the military said was you, airplane seat designers, need to make chairs that can fit people. They need to be modular and they need to be adjustable. So basically, what the Air Force said is that whatever seats you make need to fall between the 5% to the 95th percent range on every dimension. Remember, there were 10 dimensions here. So across these 10 dimensions, whatever chairs you design need to fit the 5th to the 95th percentile. So the first thing the airplane manufacturer said is they can't do it. How can you make chairs that will fit such a wide range of people, et cetera, et cetera? Now, importantly, the military is a very good customer to have, pay a lot of money, do a lot of projects. So after the initial round of complaining, the military said, well, then we'll just move on to a vendor who will. And finally, the airplane seat manufacturers realized that they can actually make adjustable seats. Now, today, it may seem very normal and standard to have adjustable seats in your car, on an airplane, or in any sort of mode of transit in which there's sort of a shared seating environment, or in which you would be engaged in some action like driving, etc., where the comfort of the seat is critical. But remember, that was not the norm. That did not exist. We had to push, and in this case, the military had to push for instead of calling for a retrofit human and rejecting the notion that human beings need to be uncomfortable and adjust themselves for technological limitations, push for the form of system that will adjust to individual needs. So, what are the key takeaways? Number one is in order for AI to work, you need to consider how to customize and build for a user. Second is you have to have clear chains of accountability and responsibility. In other words, who is building the system, who is responsible in case of failure, and what do we do if something fails? And that person cannot be the end user if they have no agency and ownership over what's happening. And then finally, achieving the gains of AI requires as much investment in the human aspect of things, understanding human beings, their needs, what they want to do with the technology, and the limitations of the technology. So you have to spend as much money on that as you do on the technical sides. Now, especially in the era of generative AI, people are constantly extremely excited about all the ways in which Gen AI can move past human beings, be smarter, better, faster, etc. But again, this has never been the case. So how can you invest not just in your compute, your data, your technical team, and your output, but also on the human side? So, how will AI impact our society? Section 2. Let's talk a bit about the future of work. Now, there's been constant conversation about generative AI and its ability to replace knowledge work. So, I'm going to talk a bit about why this is so important. So, the AI revolution has been called the fourth industrial revolution. However, the thing that is different is that all previous iterations of technology actually automated manual tasks. You think about the Industrial Revolution, it took custom building and making of goods, for example, your shoes, from a manual task to a machine task. Again, these were things that we did with our hands. Now, artificial intelligence is the first time we're automating knowledge work. And this is what's concerning people. And it is understandable because this technology can be quite impressive and generative AI is producing more and more interesting output. Now, if we want to think about the future of work, there are three papers that I'd really like to talk about. And this first paper thinks about the big picture. The second is the medium size. What is the industry level impact? And the third looks at the human worker. So let's talk about the big picture first. What are the quote simple macroeconomics of AI? Now, this is by a labor economist down at Sumoglu, and what he finds is that a non-trivial but modest impact on total factor productivity. Now, total factor productivity is the measurement of all the output of the entire world over a particular period of time. In this case, the next decade. And this does not look like the automation of all tasks. Now, it looks more like something more modest, 0.66 to 0.53% automated. Now, mind you, this is actually still quite significant. I don't want to undervalue what that means of the entire productivity of the world. About 1%, less than 1% being automated by technology is huge. But this does not look like everybody's out of a job. Empirically, interestingly, AI advances are unlikely to increase inequality. Because remember when I said that this is the first technology that automates knowledge work, not manual work. And what that means is that it's white collar jobs that are actually being impacted the most. However, this means that AI will widen the gap between capital and labor income, and also that these measurements, pure economic measurement, does not take into account negative social value. For example, manipulation, impact on democracy. And this is critically important because our world's economy is reliant on people being educated, having access to information, having access to stable economic and political systems, and more. So we cannot simply divorce the technical economic impact of AI from the broader societal implications. Now, the second paper I really like to talk about is called Automation or Augmentation, the Future of Work, and it's called GPTs or GPTs. Now, this was a paper published by OpenAI in 2023, soon after ChatGPT came out. And this is an early study. There have been other studies since. What I like about this paper is they worked with economists to find different verticals and to talk about what would be automated. And what they're finding is that approximately 80% of the United States workforce could have about 10% of their tasks affected by the introduction of GPTs, whereas about 19% may see significantly more, about 80% of their tasks impacted. And this spans all wage levels, but actually with higher income jobs facing greater exposure. Now, these are jobs like paralegal, journalists, any sort of like research and writing, basic writing function. So there is some concern about the future of work. However, it looks maybe a little bit different and a little bit more targeted than we might be thinking. Now, in the workplace, what we find is that human plus AI is greater than human without AI. And this is a lead into the third paper I really like to talk about that came out earlier this year. It's called The Cybernetic Teammate, and it's a field experiment on generative AI reshaping teamwork and expertise. So this was a collaboration between Harvard Business School with the company Procter and Gamble, and what they wanted to do was test how people and teams perform with and without AI. And the things they tested for, which I appreciate, is not just quote unquote productivity measured as completion of a task, but they looked at things like the quality of work, yes, time to completion, but also whether or not AI is automating pure knowledge work at an advanced level. In other words, how might AI augment non expert workers? Now, the next few slides are a series of graphs, and I'm going to talk you through them. So the way this was designed is there were over 900 people participating in a multi-day exercise where it was designed as a bit of a challenge. And in some cases, you had individuals, and in other cases, you had teams. These individuals were also split into people who were not given an AI system, people who were given an AI system, teams that were not given an AI system, and teams that were given an AI system. So let's walk through the findings that we have. First is that the average solution quality, if you think of the baseline as an individual with no AI system, A team with no AI system performed better than the individual. And we sort of intuitively know that groups of people have shared knowledge base. One person tackling a problem may or may not be as efficient as a group of people who are experts or used to work on a problem tackling that issue. The second is whether or not an individual plus AI did better. And actually, we found that yes, they did. So, what they find is that a person given an AI system outperformed even a whole team working on a challenge or a problem. But interestingly, that a team plus AI only performed incrementally better, slightly better. Now, if you're familiar with reading these charts and graphs, you may see this vertical line with the two bars. That is an error term. So, what an error term means is that even though the bar is at a particular point, that the actual value falls within that delta, the top and the bottom line of that bar. So, if we look at individual plus AI and team plus AI, there really isn't a discernible difference. What that means is the team plus AI could be as low as the lowest point of the individual plus AI, and maybe as high as slightly more. So I would read this graph as saying individual plus AI plus team and team plus AI had very, very similar solution quality outcomes. And also team without AI at its best could perform at around the quality of an individual plus AI, but is more likely that it actually underperformed compared to both individuals or teams with AI. And individual with no AI did not perform as well as any of the other groups. And again, this is the average solution quality. Now, the second thing they look at, which is quite fascinating, is comparing whether or not the individual or team were experts in the task. So, on one side, we have how people and teams performed when given an AI system if they were an expert in the field. And on the other side, we have how individuals and teams performed if they were not an expert in the specific task or field. This is actually a really important takeaway, very novel, unique to this paper. And I want to emphasize this quite a bit, right? When we talk about AI automating away knowledge work. Now, the clear output of this is that AI systems work best when the human or humans working with them already understand the topic of analysis. So the individuals and teams that already had a core job in whatever the task was outperformed teams given whether or not they were given AI or their comparative teams if they were not experts. So I'll show you an example. If you look at team no AI and you compare team no AI on each side, if that was not their core task, they performed quite poorly. Now, let's say you took an individual plus AI and compared to the other side. Again, an individual who was not an expert could not outperform an individual who understood the field who had AI. So the silver lining on this, and the big thing to take away, is that AI may be automating certain tasks, but you will still need human expertise in order to really take advantage of the value of an AI system. The last thing they looked at was the time saved. So, how many minutes did groups save or individuals save with and without AI systems? So, the time saved was actually, slightly higher, 4 to 8 minutes, not a significant change. But what's fascinating is that a team using an AI system did not move as quickly as an individual, which makes sense. Teams are about consensus building. I do want to emphasize that saving time is not always an assessment of anything other than spending less time on a task. It is not an assessment of quality, it is not an assessment of productivity. It is simply an assessment of how much time was spent in a given task. And what you'll find here is that individuals working alone with AI maybe moved a little bit faster than the teams, but that makes sense because teams are about consensus building. And finally, they looked at the top 10% of solutions as a measurement of quality, overwhelmingly finding that team plus AI performed the best. So there were more team plus AIs winning in the top 10% of solutions than there were any other subgroup. But remember, this is what I meant about simply saving time is not always better because these groups overwhelmingly outperformed. So the takeaway on the previous slides is that you need to understand the topics before engaging with AI. But what does that mean to be digitally literate, to engage with these topics? So, this taxonomy is from this really great book by Stuart Selber called Multiliteracies for a Digital Age. Interestingly, this book was written by an English professor about the internet. So, it's not written about AI, generative AI, machine learning, the cloud, or even big data. And what this individual did, which is quite brilliant, was separate out individuals, how they use their tools, and what it meant to be literate in using the technology. So there's functional literacy, critical literacy, and rhetorical literacy. And it depends on whether or not you are a user of technology, a questioner of technology, or a producer of the technology. So, what is functional literacy? Functional literacy is what the everyday user should have. That means that the technology is embedded in your day to day, and what you should do is learn to build and use these tools. But importantly, you need to think about how to step out of your bubble. So, if I'm using it for a particular task, how do I interact with it? How do I understand if it works? And importantly, how do I engage with the technology instead of as a result of the technology? Next, we talk about critical literacy. Now, these are individuals who may be in a position of authority or power to shift the direction of how a technology is built. So, this could be, for example, a product manager, a VP, or you could even be somebody who is a policymaker or a regulator. So, these are the kinds of questions you have to be able to ask, whether you are technical or not technical. If you're technical, you have to ask, can I interrogate the robustness of this product? Can I fix any problems that may arise? Can I create a reasonable rubric or a measurement to identify when problems may arise? And then also, can you identify if something is even going wrong? How do you challenge the system? And what is the reporting mechanism if you do find something wrong? And finally, rhetorical literacy is for the builders of the technology. So you are the person owning what is being built, how it's being built, sticking your hands in the code. And these are the questions you should ask whether you are technical or not technical. How does this product interact with society? How can you appreciate what you've built as a socio-technical system? And then importantly, where does the power lie in the systems? Who does the system benefit and how? And think through all of the topics that we have discussed so far in this lesson. We have talked about designing technology that fits people and avoiding retrofit human. We have talked about how to not build for the average and really think about how to make technology adjustable and malleable for human needs. Now, this is your opportunity to take action on these things that we're talking about. Now, how might one go about doing that? Well, I had a TED talk last year on this concept I called a right to repair. And what a right to repair introduces is methods of something I call structured public feedback. So, I've already talked quite a bit about how we need a human in the loop, and that is a phrase that is so used at this point, it is almost overused. So, human in the loop can mean many different things to many different people. Now, let's define it. So, I mentioned earlier that I've been working for over 10 years in the practice and application of responsible AI. I started my career at Accenture, the largest tech consulting firm in the world, building their practice in responsible AI. And during my time, I worked with Fortune 100 companies, big tech companies, and more on creating AI strategies and implementations. And actually, my team created the first bias detection and mitigation tool that worked at the enterprise level called the Fairness Tool. So when with all of our knowledge gained, what we did was we actually wrote a paper called Where Responsible AI Meets Reality: Practitioner Perspectives on Enablers for Shifting Organizational Practices. In other words, we wrote a taxonomy that was based on many dozens of interviews with individuals in different aspects of responsible AI. And here's what we find. How do you create human in the loop? So within the organization or company, what you need is diffuse accountability, clear and transparent processes, and success metrics for algorithms and people. If you are outside of a company, how might you create systems of addressing and redressing harms, being transparent about what systems can and cannot do, being involved in part of being outside opinions by design, and asking questions and knowing your rights as it relates to technology. I'm going to talk a little bit about what it means to build it inside of a company. Then I'm going to spend some time on what it means to start building what human in the loop means if you are not somebody who's in a company. So, first, diffuse accountability. Now, there may be a desire to create a single responsible AI leader who is solely responsible for all of the governance, evaluation, and ethical assessments of the technology. Now, simply put, that doesn't work. In no functions, risk and compliance, legal, even product development, does one individual own every end to end aspect. And as we've come to realize, AI governance is a very complicated topic and requires many different kinds of skills: technical, legal, interpersonal, sociological, and more. So, diffuse accountability means that there are many different actors who, along the way, along the supply chain, are responsible for building out this technology. The next part is clear and transparent processes. In other words, understanding who is accountable to whom and where one may escalate issues if issues arise. I do want to point out that often the individuals who have their hands on code, who have the clearest access to data and the ability to understand, are actually often the most junior employees on a team or the ones that are the least empowered. It is rare to have a VP with their hands in data doing basic data inspection and data cleaning. That's more likely a junior data scientist. Now, who does that junior data scientist go to if they're finding an issue with the technology? The next, and actually most important, is success metrics for algorithms and people. So, what does that mean? First is that we understand that there are different ways in which AI models can be measured. Now, we often measure it on things like R squared, goodness of fit, things like false positives, false negatives. Well, there are other things we can be measuring about these algorithms to determine whether or not they are actually beneficial or whether they are net harmful. Similarly, people can be incentivized via success metrics as well. Now, for example, building in reward mechanisms for individuals who are flagging issues, building in, bonuses for teams that have undergone ethical reviews. Everything does not have to be punishment based. If you're a manager or a leader trying to really inculcate a culture of responsible AI, you can actually build in ways for people to be rewarded for doing the right thing. Now, in today's world, actually implicitly or sometimes explicitly, individuals are penalized because our success metrics are just often built on pushing a system out as fast as possible, when the reality is it should actually be based on building a high quality system. Now, structured public feedback. I mentioned that I was going to talk a bit about what does it mean to be outside of an organization, pushing and advocating for ethical and responsible design. So this story actually goes from both being inside of an organization to being outside of an organization. In 2021, my team at Twitter launched the first algorithmic bias bug bounty program. So what that means is that um, we were the first company to open up our AI code and reward people for finding issues with it. Now, this is not a new practice. Cybersecurity has a long-standing history of bug bounties. Companies like HackerOne and actually my organization, Humane Intelligence, have built ways in which individuals can interact with models and be rewarded for finding these issues. And 2021 was the first time that that was actually built for algorithms. In other words, if you can find biases and issues in algorithms, then you would get rewarded. And even though I ran a combined research and engineering team on responsible use and we were conducting audits and assessments, the reality is no one team can easily reflect all of the issues of diversity, that the biases that may come up in models, um, that can happen, no matter how diverse or broad you try to make your team. And in 2022, I established Humane Intelligence, the first nonprofit dedicated to making these algorithmic bias bounties. So, how can we hold AI model owners accountable? And also, how can we create transparency within the system by creating what I call structured public feedback? Now, to be clear, there are many ways in which companies gather feedback. Usually, these are user interviews, methods of flagging and submitting flags. However, it is not clear how these issues go directly into the models, whether or not they are addressed or changed, and giving individuals access to be able to put their hand in code to really address these issues is quite meaningful. Structured public feedback is actually a method of AI assurance. Now, to be clear, assurance is different from audit, and assurance is defined as determining whether the model or model safeguards are operating as expected. In other words, if you are promising some sort of performance of your model, then assurance tells you whether or not that actually happens. Now we have three methods of structured public feedback. I had mentioned bias bounties. Now these are open challenges for narrowly scoped issues. They are good for testing frameworks, and they're good for crowdsourcing answers to a very specific problem. So you have an issue with your AI model. You want to get a diversity of input on ways in which it can improve, or maybe finding a solution, and you crowdsource that. Expert red teaming is when you have closed challenges for invited experts in a field. And what that is good for is testing narrow harms in very specific issues, as well as supplementing existing internal red teaming work with external expertise that is currently lacking within your team. Now, this is usually beneficial for things that you would have to get a degree in, for example, particle physics or chemistry or sociology or linguistics. Also, we have public red teaming, and these are invite only or fully open at scale challenges to a wide range of individuals. And these are good for measuring societal or diffuse harms or gathering data in mass to identify systemic issues versus point issues. Now, what does that mean? What that means is public red teaming is often based on individuals' lived experiences in society. Maybe this is not maybe something you get a degree in, but is often things that are overlooked when people are making AI systems, in part because we lack the diversity needed for AI to be truly impactful for everybody on the planet. And a few years ago, my nonprofit, along with others, tested the limits of AI technology at the largest ever, still the largest ever, generative AI red teaming challenge, where over 2,500 people worked on challenges related to the AI Bill of Rights as implemented, and we worked with every single model owner. As you can see by my quote here, what I state is that we need people with a wide range of lived experiences, subject matter expertise, and backgrounds hacking at these models and trying to find these problems. And also, earlier last year, we worked with the US government and the National Institutes for Standards and Technology for a broad public red teaming exercise where anybody in America could interact with AI systems and provide feedback. Now, this quote is from the Chief of Staff at Humane Intelligence, where we talk about how whether or not human input from a wide range of people was actually valuable, and it is. We want to democratize the ability conduct evaluations, and make sure that everyone's using these models can understand for themselves whether or not the model is useful and meeting their needs. So we're working with a wide range of government, civil society organizations, and more to actually create public access to these models in a safe and secure fashion to help identify a broad range of issues. Now, the next step is creating something called an AI right to repair. Now, red teaming is simply a starting point for this. And the question you want to ask is how might the average person be a part of addressing harms in AI models? Red teaming is simply a starting point. What red teaming does is it actually creates the ability for people to engage with models in a way that is quite different. Remember when we talked about critical literacy, I said something like engaging with an AI model versus as a result of it. Today, the way the interaction with most generative AI models are established, it's established as if we are meant to take action as a result of the output of the AI model, instead of having it be an iterative exercise where you actually have some control or ownership. Also, remember when I was talking about the individuals with the adjustable seats. Now, right to repair, imagine that as being kind of like this adjustable seat, right? So, right to repair might mean that. That you would have the ability to interact with the system, and if you identify issues, be able to flag it in a way that is meaningful and that you would be able to see the repairs and improvements happen. And as we continue to build bigger and bigger AI systems, for example, agentic AI systems to do tasks for us, well, we need to make sure that the way these AI models are performing are ways in which actually it meets our needs and it does what we want it to do. So, what's next? How should you be thinking about the future of responsible AI? It is worth your time to invest in understanding artificial intelligence. Now, the first thing to think about is that AI is a productivity tool, plain and simple. Treat it as one. Remember, as we saw in our analysis of the future of work, a human with expertise plus AI will always outperform a human with no expertise plus AI, and a human not using an AI. So utilize this productivity tool to help you be better at what you're doing. Next, if you are a builder, or if you're a user, or if you are somebody who has any sort of agency over these systems, consider the intersection of what your pain points are and what AI is good at doing. Where do they intersect? In other words, if you're building a tool for somebody, ask yourself, am I building something for a retrofit human? Am I asking people to adjust the limitation of the technology? Or am I understanding users' needs? This may be a time to invest in things like test and evaluation mechanisms, such as red teaming or red teaming at scale. And then finally, the question to ask is, how can you utilize AI to solve problems positively and productively? In other words, when you have AI systems and you want to create solutions, first of all, make sure that this is a problem that people want to use AI for, that they're comfortable with using AI, that the AI is trustworthy, you've done your testing and evaluation, you've understood your problem and your pain points, and you've adequately put a human in the loop, and that this individual is rewarded for making the right decision, even if that decision introduces friction into the system. Thank you so much for your time. Again, my name is Dr. Rumman Chowdhury. You can reach me at www.rummanchowdhury.com.